On November 19, SpaceX took a major step forward in its Starship development program with the sixth flight of the most powerful and innovative rocket ever built for space exploration. The launch marked a new phase in the testing process for Starship and the Super Heavy booster rocket, with a more ambitious goal than previous flights. This flight was similar to the fifth one, conducted just 5 weeks earlier, but included some modifications that made it more significant, even though the attempt to catch the Super Heavy mid-air was not carried out. However, SpaceX successfully completed one of the most critical tests, firing the Raptor engine in space. Let's explore how it went this time, what developments took place, and what we can expect from future Starship flights. Starship lifted off as planned, with a half-hour margin during the launch window. One of the most notable aspects of this test was that, for the first time, SpaceX opted for an afternoon launch rather than the more traditional times of previous flights. In Texas, the launch occurred at 4 p.m. local time, and the rocket took off as scheduled. This change allowed Starship to complete its journey over the Indian Ocean during daylight hours, enhancing the visibility of the flight's key moments. The ignition of the Super Heavy booster's 33 Raptor engines occurred without issues, and the engines remained active for about 2 minutes and 37 seconds. After this period, 30 of the engines were shut down, leaving only the 3 central engines burning. The separation between the first and second stages proceeded as planned, with the ignition of Starship's 6 Raptor engines enabling it to detach from Super Heavy. This was a critical step, as the separation and subsequent engine ignition were executed flawlessly, marking another success for the program. After separation, the Super Heavy rocket performed a boost backburn, igniting its engines to reverse trajectory and prepare for atmospheric re-entry. However, at this stage, SpaceX decided not to attempt catching the rocket mid-air with the Mechazilla tower, as initially planned. This decision was due to an issue with the capture tower, confirmed a few hours after the launch. The problem was not with the Super Heavy itself, but the tower was unable to support the catch during the flight. Nonetheless, the booster successfully completed its re-entry into the Gulf of Mexico with precision. Upon touchdown, the Super Heavy tipped to one side shortly after splashdown. A small explosion followed, likely caused by methane fuel venting from the tanks, rather than the Flight Termination System (FTS). The booster remained afloat, and flames from the damaged area persisted for several minutes. As for Starship, after separating from Super Heavy, it continued its orbital flight phase, achieving significant velocity thanks to its 6 Raptor engines. These engines propelled Starship for 7 minutes and 55 seconds before the 3 vacuum-optimized engines were shut down. Starship reached an altitude of 149 kilometers before turning off all central engines. Although this altitude was lower than the 213 kilometers reached in the previous flight, it was an intentional maneuver to facilitate the flight's most important test, firing the Raptor engine in space. An intriguing detail about this flight is that Ship 31 became the first Starship to carry a payload into space, a small symbolic gesture that captured the imagination of many space enthusiasts. Starship carried a banana in its payload bay, a nod to SpaceX's merchandise, along with a small toy as a travel companion. Additionally, the side of Ship 31 featured an illustration of a banana holding another banana, referencing the whimsical payload contents. This light-hearted addition brought a human and creative touch to what was otherwise a technical test. Moreover, Starship showcased a new Starlink satellite deployment system, allowing SpaceX to test the structure's behavior during flight. Although no satellites were deployed during this test, the cargo and deployment system represents a crucial step for future missions involving Starlink or other orbital payloads. The most critical test of this flight was undoubtedly firing the Raptor engine in space. This engine, one of Starship's 3 central engines, is designed to operate in a vacuum and was fueled by auxiliary tanks using leftover propellant from the launch. The main tanks were nearly empty during this test, simplifying propellant management. The engine's burn was brief but sufficient to gather significant data on its behavior in microgravity and vacuum conditions. This test marks a fundamental step in refining Starship for future missions to the Moon, Mars, and beyond. In the final stage of the flight, Starship undertook atmospheric re-entry, facing a steeper angle of attack than in previous flights. This generated higher temperatures during re-entry, creating intense plasma around the rocket. However, the thermal protection system performed as expected. SpaceX used older generation tiles for the thermal coating but installed new insulation material beneath them, allowing for the collection of crucial structural data during re-entry. In the final minutes of the flight, Starship maneuvered to reduce its speed and orient itself vertically. This orientation was achieved through aerodynamic control surfaces, followed by reigniting the 3 central engines to slow down and ensure a controlled splashdown. The maneuver was successfully executed, and Starship splashed down at the designated location, as confirmed by telemetry and buoys in the area. This was a key test to evaluate Starship's ability to safely land in aquatic environments and prepare for future missions where water landings might be necessary. During the flight, SpaceX also showcased the updated Starship, Ship 33, which features larger tanks capable of holding 1,500 tons of propellant compared to the 1,200 tons in previous versions. Additionally, Ship 33 includes a hatch for deploying Starlink satellites, confirming that upcoming flights might carry payloads into orbit. Furthermore, SpaceX unveiled the Starship V2, designed to serve as a refueling tanker for space missions. The rocket will launch into low Earth orbit to refuel Starship before missions to the Moon and Mars, marking a significant step in SpaceX's plan to colonize the solar system. Elon Musk stated that SpaceX's goals are highly ambitious, and it is impossible to predict every aspect of the process. Nonetheless, this launch represents an important step forward for Starship and SpaceX's entire space program. Despite some technical issues, SpaceX has once again demonstrated its resilience and adaptability, moving closer to making space travel a commercial and futuristic reality. Thank you for watching. If you enjoyed, leave a like, subscribe to the channel, and turn on notifications so you don't miss the next videos.